So domain and range are with straight lines, linear. We've done exponential before. That's the curve upward. We've done absolute value. Absolute value is a V-shaped. So a quadratic function is ax squared plus bx plus c. That's the format, right? It has a little exponent of a 2. That's how you know that it's a quadratic, because there's a 2 in the exponent spot. The domain is going to be the x-axis. I always look from left to right. And it's going to be, where is my line? And this parabola that you have has little teeny arrows that go. This arrow means that it goes forever upwards to the left, up, 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 up. It's going to go over, like, Acacia School, over, next city over is what? La Mirada? All the way over there. Negative infinity. Left to right. Left to right. Right is going to be upward over Cal State Fullerton. Eventually, it'll be really high. Over Placentia, next city over. After Placentia is Yorba Linda. So from negative infinity to positive infinity, my parabola line is going to eventually, like, get to all those places. So in a quadratic function, most of the time your domain is going to be negative infinity to positive infinity. I can also use this R to say all real numbers. But it's important that you know you go from left to right. Left to right. In my range is up to down, low to high. You start low, like by negative infinity, and you're scanning up. Where is my graph? Where is the black line up here? I use notation like, where should I put it? I guess it's fine. Parentheses would be an open circle. That means not included. A bracket would be a closed circle. That means included. That the line is on the number. So we're going to use some parentheses and brackets today. And it's important that we know the difference. I also put it on the board up here. It used to be here maybe like 2 months ago, but I put it back up. This is where you've seen it before. So let's look at number 1. I am scanning domain from left to right. So that means, and yes, there's arrows everywhere. Please note that there should be arrows here. If I scan, I'm going to use my pencil. You can use your finger, a ruler, whatever. Left to right. The parabola would go downward. Wouldn't it be over here where my pencil is, but just really low? So this parabola is going to go down, down, down. It's eventually going to get more left to negative infinity. And then I'm like, yes, it's here. Yes. Scanning to the right. Yes, yes, yes. It hits, it hits, it hits. Scan, scan. It's going to go forever down. Right, right, right. It's going to eventually hit positive infinity. So I can say domain, negative infinity to positive infinity. All real numbers. I'm not going to write them both, but for the first one I will. Because when I scan, this arrow goes forever, more to the left, more left. It's eventually going to be at negative infinity. And then I scan. Yep, it's hitting my arm. Yep, it's hitting my arm. Yep, it's hitting my arm. Well, and if it continues down, it's going to continue to hit my arm, just way low to the ground. The line goes forever to the right. Range is low to high. So I'm only looking at number 1. If the arrows go down, aren't they going to hit my arm on the ground here? Because the arrows keep going, the line keeps going down. So this is like negative infinity way down here. So my parabola for number 1 is going to hit here. I just can't see it because the paper. And here, and here. And tell me where it stops. It stops here. What is this at? 1, 2, 3. It's at 4. It's actually touching the line at 4. 1, 2, 3, 4. So since it's touching at 4, it stops at 4. So the range, low to high, is going to go from negative infinity, low, and the highest it goes is 4. And it stops at 4 and it touches at 4. I put a bracket at 4 because it's included. It's a solid line and it hits at 4. It's not a dotted line. It's a solid line and it's touching 4, isn't it? But it doesn't go to 5. It stops at 4. 4 is where it stops. Negative infinity, down underneath the school, everywhere. Negative infinity up to 4. My vertex is the ordered pair. Right there. What's that ordered pair labeled? What? 1, 4. Yeah. Thank you. So, the difference between max and min. Maximum means it tops out. Minimum means it bottoms out. Maximum means it only goes to a certain spot and that's the highest it goes. This only goes to 4 and that's the highest it goes. That's a maximum. The max that it goes is 4. So I'm going to say, is it a max or a min? It's maximum. So your answer, you're going to write the word max. Maximum, whatever you want for abbreviation is fine. Does this open up or down? Does the parabola open up or down? Down. Opens down. Okay, number 2. Domain. This is an upward facing parabola. The arrow is going to go forever left. That's negative infinity way over there. Positive infinity way there. So the domain is all real numbers, which is negative infinity, positive infinity. Negative infinity to positive infinity. The range. All right. You look at the parabola. Everybody with me? Gavin. Is my parabola down here on number 2? No. This is like negative infinity. It's not down here. It's not down here. So, where does it start? Negative 3. Negative 1, negative 2, negative 3. It starts at negative 3. Is it touching negative 3? Is it on negative 3? That's a bracket. Negative 3, low to high. The lowest point it hits is negative 3. What's the highest it goes? 2, negative 2, negative 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, infinity. Up, up. Infinity always has a parentheses. Infinity always has a parentheses. My vertex is an ordered pair. What is the vertex? Someone knew. 2, comma. Easy. Is this easy, you guys? Oh, awesome. This has a low minimum. It bottoms out. Minimum. And does it open up or down? Up. Easy, right? Yeah. These are all the same thing. And you have homework problems that are just like this. Totally like simple. I will do number 3. Can you guys not do number 4? Please hold. Number 3. Mr. Tovar, are you with me? Hi. Domain. All real numbers, guys. Left, right. Negative infinity to positive infinity. And then range. It does not get to negative infinity way down there. No. Where does my parabola begin? 0. That's my low point. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Infinity. Low to high. Range is low. 0. Oh, it touches 0. Bracket 0. And it goes up to infinity. Low to high. That's what you need to memorize the difference between. Domain goes from left to right. Range goes from low to high. Label the vertex. So you always go left or right first. 2 to the left. And nothing up. Negative 2, comma 0. I only use the brackets and stuff for domain and range. Vertex is always just going to be parentheses. Minimum, because it has a low point. And it opens upward. The reason we were holding on number 4 is because I want you to do number 4 as a group. So the people next to you, number 4. The group. Go ahead, do number 4 together. You'll talk to each other.
So first of all, right, Betsy, listen. I'm scared.
Okay, what'd you put? Number 4, what'd you put for the domain? All real numbers. Negative infinity to positive infinity. Range, low to high.
Negative infinity, positive 1.
Oh, it's not negative infinity. The lowest point is not negative infinity. It doesn't go down here. 1, bracket 1, comma, up to infinity. Bracket 1, comma, infinity, parentheses. This matters. All these little details matter. My vertex. Is it 1, 0 or 0, 1? because that's my y-intercept. 0, 1. Good. Is it a max or min, class? Because it has this low minimum point. Bottom opens up. Okay. I don't want to do 5 and 6 because we have practice problems on the back. There's two more things. There's a whole practice worksheet, and then there's your homework worksheet at the end. So, let's do 2 of these, and then we'll do some of 7 through 12. One upward, let's do 3 and 5. Sure. I have to label myself domain D, range R, vertex. I'm just going to write that I know it's a minimum because I'm looking at it and it has a low minimum point. And then it opens up or down, it opens up. So, domain, it goes left to right. Domain is left to right. Negative infinity to positive infinity. And then range, low to high. Hold on, don't answer every question. I love that you know it, but other people need to try. So, nope. It doesn't have negative infinity in it. Where does it start? -4. Bracket -4, and then it goes up forever to infinity. Okay. Vertex. Over what? Down what? Vertex, number 3. Good, I'm glad it's quiet because that means that my normal people are not helping. I don't want them to.
-1, -4.
-1, -4. Good. All right, number 5. D, R, V. So, do number 5. All right, you're doing number 5 right now. You're doing number 5 right now. Oh, you did all of them? That's good practice. You'll be fine. Okay. How about people that really aren't helping me quite yet? Table 5. You raised your hand. Table 5. What's the domain? Negative infinity. Good, to positive infinity. Okay. You want to tell me the range? Go ahead. Hold on. So it starts low. Lowest point is negative infinity. So I'm going to put negative infinity first. Because it's lowest. What's my lowest point? Start below, down. Negative infinity up to 6. Comma 6. Bracket at 6 because it touches 6. My vertex. Table 4. Table 4, what's my vertex? 0.6. Table 8. Does it open up or down?
Down.
And then is that a max or a min, Holden? It is a max. Good. Okay. So, you guys, this is pretty much the same as what we were doing on the front side. So that's fine. Down here, we did this last week. X-intercepts. I have to factor to find x-intercepts. So let's factor some of these. Let's do a lot. Number 7. Factoring means I figure out the 2 parentheses. Remember that? I'll show you. Set this, instead of y, put a 0. What 2 numbers multiply to make a 1, but add to a 2? Go on mute. Go on mute. Both of you, go on mute. Okay, I multiply 1 times 1. Obviously, the only way that I can make x squared is x in the first positions. And then my signage. Because you can test it out by outside, inside. How do I make 2? Okay, and then you now, Miss Janaea, are on mute. I figured out that I have an x plus 1 and an x plus 1. X plus 1 equals 0. X plus 1 equals 0. You solve for x. Just subtract 1. Solve for x. Turns out they're at the same spot. Let me show you what this would look like. My x-intercept would be at -1. Like that. If I had to graph it. I don't have to graph it. If I did. Okay. How do we know that these are quadratics? What's the giveaway that these 6 problems are quadratics? The squared. If it doesn't have an x squared, like if it's y equals mx plus b, I'll write that. Like if it's a y equals mx plus b, that's just linear. So, 8, 9, 10, 11 are going to be okay. I'll do another one, but I really want to do 12. Because 12 is in a different format than we've seen. 12 has this x plus 2 and then a squared. I have to do x plus 2 twice. And then the minus 25 is just going to be at the end. You have to FOIL that x plus 2, x plus 2. You can't have parentheses in a standard form. So write it twice, FOIL it. First, outside, inside, last. Remember that? So, first, x times x, x squared. Outside, x times positive 2. What's inside? 2 times x. What is that? Just, no, 2x. It's okay. What's my last? 2 times 2? You're on mute, remember? Okay. Combine like terms. Get it into a trinomial. 3. This are like terms? 4, negative 25, those are like terms? X squared plus 4x, what's 4 minus 25?
21. Negative 21.
All right, negative 21. Now, I need two numbers that multiply, because now it's ready to go, ready to factor. Multiplies to make 21, adds up to 4. You're not. No. You're the first person the camera hears. Right here. You too.
Really?
Uh-huh.
I'm sorry. Hi, subscribers.
Hi, subscribers. All right. 21, what'd you say? 21. 7 and 3. Obviously, x squared is x times x. A lot of students have trouble figuring out the signs. I want a 7x and a 3x to make a positive 4. That's my outside, inside. It's not that. Try again. Positive 7 and negative 3. That makes a positive 4. You're not done. You have to set them equal to 0. X plus 7 equals 0. X minus 3 equals 0. And solve for x. My 2x intercepts are at negative 7. And solve for x. And at 3. Pick another one, 8, 9, 10, or 11 that you want to see that maybe looks tricky for you.
8.
No. A number that has like in front, an 8, 9. I like 9 better than 8. I think 9's harder. Okay. So, 4. Well, that could be 4 times 1 or 2 times 2. You have to try both. When you multiply by 4 on anything, you're going to get a really large number. So smaller numbers like 2 times 2, let's try that first. And I'm writing in pencil because I might have to erase. Maybe I get it wrong. What makes 3? There's only one. There's only 3 times. Yeah. But is it 3 times 1 or 1 times 3? I don't know. 3 times 1 or 1 times 3? So you have to play around. Outside, 2x, 6x. This is the 2x and this is the 6x. Does 6x and 2x make 8?
Yes.
6 and 2 make 8. So it's 2x plus 3, 2x plus 1. And you would check it, just if you want to verify and get 100% on everything, FOIL it and check it. So, 2x plus 3 equals 0. 2x plus 1 equals 0. And then just solve for x. This, though, I don't want you to just copy off me. Isolate the x, move the 3. Da-da-da, go, go. When I have a 2x plus 3 equals 0, what's my x value? You're doing number 9. You're solving for x. So what is it? No, I did. I gave him that last week. But I wrote people's names on it that didn't get. Okay, hold on. I'm recording. I can't do this right now. What you got? X equals what? X equals what? Not -6, no. But you're on mute. 3/2. He subtracted 3, and then he divided by 2. -3/2, which is the same as -1 1/2 when you change it to a mixed number. And then 2x plus 1 equals 0. You have to be able to do that. What is it? -1/2. If I were to graph that, -1/2 and -1/2, I guess I better draw it on the paper. -1, -2. -1/2 would be like in between 0 and -1, like there. That's -1/2. -1/2 would be there. So my parabola would look like something like that. And I know that it's upward because it's a +4. Okay, you guys do 11. Do 11 by yourself. Factor it. Number 11, go. What is it? Well, the first, what makes 5x squared? 5x and x. What makes 4? It could be 4 times 1. It could be 2 times 2. You play around with it. Did anybody get it? What'd you get? 2 and 2. Because when he tested it, he got a 2x and a 10x. 10x and 2x make 12. But they both are going to be negative. So then you have to set 5x minus 2 equal to 0 and x minus 2 equal to 0. Okay. And then you solve for 0. You need to practice that on your own. So, I want to talk about this homework paper. So, like, on number 4A, you would factor it as normal. 4B, you guys, this is not a quadratic. State if it's a quadratic function. No, this is linear. So actually, in order for me to solve for x, to find the x-intercepts, I would set y equal to 0. and you solve for x. You can do that one on your own. I just started it for you. On on C, you need to write x minus 3 twice and FOIL it before you can actually factor it. Same thing with E. Write it twice. Okay? And then, set it equal to 0, and then you can factor it. So your job is to do 1 through 4 for homework, this whole last page only.